Hello everyone. Today we are going to start atmospheric pressure. It is a fundamental concept in meteorology. Different contents we are going to study is first we are going to see what do you mean by atmospheric pressure, how we are going to measure atmospheric pressure, what are the various factors affecting the air pressure and how and why this air pressure is important. So without further delay, let's start with the topic. Atmospheric pressure can be defined as a force exerted by the Earth's atmosphere on a given area. Imagine a column of air stretching from the ground all the way to the top of the atmosphere directly above you. Now, atmospheric pressure is the weight of all those air molecules in that column pressing down on you at that particular time. Atmospheric pressure is typically measured using an instrument called as barometer. This is why it is also known as barometric pressure. This barometer was invented by an Italian scientist, Evangelista Torricelli. A rising barometer indicates increasing air pressure, and a falling barometer reading indicates a decrease in atmospheric pressure. There are various units used to measure atmospheric pressure. Some of them are atmosphere, millimeter of mercury, torr, pascal, bar, pound per square inch. Out of these, the most commonly used units are millibar and inches of mercury. However, the SI unit of atmospheric pressure is Pascal. On an average, the air pressure at sea level is taken as 1 atmosphere. So 1 atmosphere and their conversion is into various units are 1 atmosphere is equal to 1 lakh 1325 Pascal, which is equal to 1.01 bar. Also, 1 atmosphere is equal to 760 millimeter of mercury, which is equal to 760 torr, which is also equal to 14.7 pound per square inch. Now, atmospheric pressure is an essential element which affects atmospheric condition. It varies from place to place and time to time. The factors affecting atmospheric pressure are first altitude, temperature, rotation of earth and humidity. So let's study them one by one. First is altitude. We know that air pressure is the pressure created by the air molecules at a place. More the number of air molecules, more is the pressure. Since gravity holds the air molecules together near the surface, this increases the density and ultimately weight of the air, and we find a higher pressure at near the ground. However, as we go up, the amount of air molecules decreases simply due to the decrease in gravity, decreasing the weight of the air, resulting in low density, and subsequently we have low atmospheric pressure. So we see that as the altitude increases, it results in decrease in the atmospheric pressure. Thus, we can say that atmospheric pressure has an inverse relationship with the altitude. The next factor is temperature. We know that the solar radiations heat the ground, which will then heat the air above this. The heated air molecules gain the energy and they start moving faster and away from each other. Thus, they expand the air. This means when we measure the air molecules per unit area, it is less. Less molecules means less density, means low pressure. In short, high temperature leads to low pressure. Likewise, cold temperature result in contraction and condensation of air molecules. The air now becomes dense and we find a greater number of molecules per unit area, resulting in high pressure. This is the reason why we have high pressure zones in pole while low pressure zone in the equatorial area. In the end, we can say atmospheric pressure has an inverse relationship with temperature. The third factor is rotation of Earth. The rotation of Earth creates a force called as Coriolis force. This force deflects the moving air from its original path. It deflects the air to the right in the northern hemisphere and to the left in the southern hemisphere. The deflected air will diverge at subtropical region, meaning at 30° north and south, the air will move outwards due to the Coriolis force and create high pressure zone called a subtropical high. Conversely, the deflected air will converge at subpolar region, meaning at 60° north and south, there will be an inflow of the air due to the Coriolis force and create low pressure zone. Thus, deflected Thus, we can say deflection is responsible for creation of alternate low and high pressure zones on Earth, which is crucial for wind formation both at local level as well as global level. The last factor is humidity. Humidity can be defined as the presence of water vapor in the air. Since water vapor is lighter than both nitrogen and oxygen, when the amount of water vapor in the air increases, it displaces some of the heavier nitrogen and oxygen molecules, making it less dense. Thus, we can say increase in humidity contribute to low pressure whereas low humidity results in higher pressure. Now we have come to the last section of the topic, that is importance of atmospheric pressure. So the first importance is wind formation. Atmospheric pressure is the fundamental driving force behind wind formation. Winds are simply defined as horizontal movement of air. When air is heated, it becomes light and it will rise. As it rises, it leaves behind an area of lower atmospheric pressure at the surface. Contrary to this, cold air is dense and it will sink down. It gets accumulated at the surface, creating an area of higher atmospheric pressure. To equalize the pressure difference, air starts to move from high pressure area to the low pressure area. The greater the difference, the stronger and the faster the wind is. The next point is weather formation. We all know that the air in the high pressure area sinks down, and in this process, it will get heat warmed up. Hence, we can say that air in a high pressure area is dry in nature. Due to this, there is no cloud formation, which leads to a fair weather and clear sky. We have to understand that with clear sky, temperature of the place can fluctuate more widely. Days can be warmer due to more direct sunlight, and nights can be cooler as heat radiates more easily into the space. Similarly, air in a low pressure area rises and in the process it will cool down. Hence, we can say that air in a low pressure area is wet in nature. This leads to condensation of water vapor forming clouds, and often it leads to precipitation. Also, due to the cloud cover, there is minimum fluctuation in day and night temperature. The next factor is movement of ocean current. Surface ocean currents are the continuous movement of surface ocean water. Atmospheric pressure plays a crucial role in its movement through winds. When the wind blows across the ocean surface, they transfer their momentum from the atmosphere to the ocean, causing water to move. These are important as they regulate the global climate by redistributing the heat from the equator towards the pole. Thus, they influence regional temperature and weather pattern. This also allows vertical mixing of water. This means the deeper, nutrient rich water comes to the surface. This process is called as upwelling. It is important for the sustenance of marine life. A prime example of the interconnectedness of atmospheric pressure and ocean current is the El Nino Southern Oscillation phenomena. The next factor is movement of ocean current. Surface ocean currents are the continuous movement of surface ocean water. Atmospheric pressure plays a crucial role in its movement through winds. When the wind blows across the ocean surface, they transfer their momentum from the atmosphere to the ocean, causing water to move. These are important as they regulate the global climate by redistributing the heat from the equator towards the pole. Thus, they influence regional temperature and weather pattern. This also allows vertical mixing of water. This means the deeper, nutrient rich water comes to the surface. This process is called as upwelling. It is important for the sustenance of marine life. A prime example of the interconnectedness of atmospheric pressure and ocean current is the El Nino Southern Oscillation phenomena. Change in the atmospheric pattern across the Pacific Ocean leads to the weakening of equatorial trade wind, which allows warm water from the western Pacific to surge eastward, fundamentally altering the ocean current and leading to widespread climate change. The next is atmospheric pressure and human physiology. Atmospheric pressure is a constant force exerted on the human body. Yet, it doesn't crush us because an equal amount of pressure is present in our body, thus creating a state of equilibrium. This equilibrium is crucial for breathing. Breathing allows oxygen to enter the lungs and carbon dioxide to be expelled. Any change in this external pressure can create an imbalance and various physiological effects. For instance, when there's a rapid change in atmospheric pressure, particularly during an airplane ascent or descent, our ear pops to equalize the internal body temperature to that of the external air pressure. At higher altitude, the descent in air pressure can cause headache, nausea, vomiting, leading to what is called as altitude sickness. Similarly, when a person dive deep into the underwater, the rapid increase in the pressure can cause the dissolved gases in our body and tissues to form bubbles. These bubbles can then block the blood flow and can cause organ damage. This condition is called as decompression sickness. Even astronauts wear the space suit primarily to manage the pressure, as there is no atmospheric pressure in the space, which could lead bodily fluid to boil and other harmful effect. The next important factor is boiling point of water. The boiling point of water is directly affected by the atmospheric pressure. Increase in the atmospheric pressure leads to higher boiling point, and decrease in the atmospheric pressure result in lower boiling point. This happens because the boiling point of any liquid is the temperature at which its vapor pressure becomes equal to the surrounding pressure, generally the air pressure. So if the atmospheric pressure is low, liquid will boil faster. Hence, at sea level, water boils at 100 degrees centigrade, whereas at higher altitude, it will boil at lower temperature and much faster. In conclusion, we can say that atmospheric pressure is a fundamental atmospheric variable that profoundly influences not only our planet's weather and climate, both at global as well as local level, but is also needed for the working of our everyday tools like drinking straws, syringes, rubber tires, balloons, aircraft flight, and many more. Understanding atmospheric pressure, its measurement and units, its variation and importance is very crucial. In the next video, we will try to understand the various pressure belts on Earth and weather phenomena like cyclones and anticyclones in detail. If you have any doubt, please do comment. Thanks for watching.